Welcome to ISINTC, IT Infrastructure and Network Technologies. Module 2, Network Devices, Network Cabling, and Network Topologies. Hub, switch, and router. To connect multiple segments of networks into a larger one. Hub, a multi-port repeater to enhance signal within the same LAN. A network hub is a device that allows multiple computers to communicate with each other over a network. It has several Ethernet ports that are used to connect two or more network devices together. Each computer or device connected to the hub can communicate with any other device connected to one of the hub's Ethernet ports. Hubs are similar to switches but are not as smart. While switches send incoming data to a specific port, hubs broadcast all incoming data to all active ports. For example, if 5 devices are connected to an 8-port hub, all data received by the hub is relayed to the 5 active ports. While this ensures the data gets to the right port, it also leads to inefficient use of the network bandwidth. For this reason, switches are much more commonly used than hubs. This is an example of a hub. Switch. It is like a hub but with intelligence, and it has better performance. A switch is used to network multiple computers together. Switches are more advanced than hubs and less capable than routers. Unlike hubs, switches can limit the traffic to and from each port so that each device connected to the switches has a sufficient amount of bandwidth. For this reason, you can think of a switch as a smart hub. However, switches don't provide the firewall and lagging capabilities that routers do. Routers can often be configured by software. It is typically via a web interface, while the switches only work the way the hardware was designed. So this is an example of a switch. Router. It forwards packets from one LAN to another. A router is a hardware device designed to receive, analyze, and move incoming packets to another network. It may also be used to convert the packets to another network interface, drop them, and perform other actions relating to a network. A router acts like a coin sorting machine, allowing only authorized machines to connect to other computer systems. Most routers also keep log files about the local network activity. So this is an example of our router. Transmission media. There are two main categories. We have guided and unguided. Guided media. In this type of media, signal energy is enclosed and guided within a solid medium. The guided media is used either for point-to-point link or a shared link with various connections. In guided media, interference is generated by emissions in the adjacent cables. Proper shielding of guided media is required to reduce the interference issues. Unguided media. In the unguided media, the signal energy propagates through a wireless medium. The wireless media is used for radio broadcasting in all directions. Microwave links are chosen for long-distance broadcasting transmission and guided media. Interference is also a problem in unguided media. Overlapping frequency bands from competing signals can alter or eliminate a signal. So for guided media, we have twisted pair cables. Example, we have unshielded twisted pair or UTP cables. And we also have shielded twisted pair or STP cables. We also have our coaxial cables and our fiber optic cables. Twisted pair cables. A twisted pair cable is a type of cable made by putting two separate insulated wires together in a twisted pattern and running them parallel to each other. If the pair of wires are not twisted, electromagnetic noises from motors will affect the closer wire more than the farther one, thereby causing errors. A twisted pair cable is a type of cable made by putting two separate insulated wires together in a twisted pattern and running them parallel to each other. This type of cable is widely used in different kinds of data and voice infrastructures. So these are example of how our twisted pair cables work and how noises are controlled. So experts point out that twisted pair cabling is often used to help avoid a certain kinds of signal interference. Unshielded twisted pair or UTP. It is typically wrapped inside a plastic cover for mechanical protection. A sample UTP cable with 5 unshielded twisted pairs of wires. UTP cable is a 100 ohm copper cable that consists of 2 to 1,800 unshielded twisted pairs surrounded by an outer jacket. They have no metallic shield. This makes the cable small in diameter but unprotected against electrical interference. The twist helps to improve its immunity to electrical noise and electromagnetic interference or EMI. The wires are typically made of copper with polyethylene or PE insulation, which is color-coded depending on the application of the cable being made. This is another example of our UTP cable. Shielded twisted pair. STP cables are similar to UTP cables, except there is a metal foil or braided metal mesh cover that encases each pair of insulated wires. Shielded twisted pair cable encases the signal carrying wires in a conducting shield as a means of reducing the potential for electromagnetic interference. How effective the shielding is depends on the material used for the shield, its thickness and frequency, the type of electromagnetic noise field, the distance from the noise source to the shield, any shield discontinuity, and the grounding practices. So STP has the individual pairs of wires wrapped in foil, which are then wrapped again for double protection. Categories of UTP cables. Electronic Industries Alliance or EIA classifies UTP cables according to the quality. We have the Category 1. This is the lowest quality, only good for voice, mainly found in very old buildings, and it is not recommended now. So Category 1 UTP used in telephone lines with data rate of less than 0.1 Mbps. Category 2, good for voice and low data rates, up to 4 Mbps for low-speed token ring networks. Category 2 UTP used in transmission lines with a data rate of 2 Mbps. Category 3, at least 3 twists per foot for up to 10 Mbps, and very common in phone networks in residential buildings. Category 3 UTP used in LANs with a data rate of 10 Mbps. Category 4, up to 16 Mbps, and it is mainly for token rings. It is used in token ring networks with a data rate of 20 Mbps. Category 5, or we also have the Category 5E, and it is up to 100 Mbps, common for networks targeted for high-speed data communications. It is a UTP used in LAN with a speed of 100 Mbps. And we have our Category 6. It has more twists than Category 5 and up to 1 Gbps. So Category 6 UTP is used in LANs with a data rate of at least 200 Mbps. Coaxial cables. In general, coaxial cables or coax carry signals of higher frequency from 100 kHz to 500 MHz than UTP cables. The outer metallic wrapping serves both as a shield against noise and as the second conductor that completes the circuit. Coaxial cable is a type of copper cable specially built with a metal shield and other components engineered to block signal interference. It is primarily used by cable TV companies to connect their satellite antenna facilities to customer homes and businesses. It is also sometimes used by telephone companies to connect central offices to telephone poles near customers. Coaxial cables have concentric layers of electrical conductors and insulating material. This construction ensures signals are enclosed within the cable and prevents electrical noise from interfering with the signal. The center conductor layer is a thin conducting wire, either solid or braided copper. A dielectric layer made up of an insulating material with very well-defined electrical characteristics surrounds the wire. A shield layer that surrounds the dielectric layer with metal foil or braided copper mesh. The whole assembly is wrapped in an insulating jacket. The outer metal shield layer of the coaxial cable is atypically grounded in the connectors at both ends to shield the signals and as a place for stray interference signals to dissipate. We have our fiber optic cables. Light travels at 3 by 10 to the power of 8 milliseconds in free space and is the fastest possible speed in the universe. Light slows down in denser media, that is, for example, a glass. Refraction occurs at interface with light bending away from the normal when it enters a less dense medium. Fiber optic cable is an advanced type of network cable offering significantly improved performance in terms of bandwidth and data carrying than traditional metal conductor versions. Optical fiber cabling is used to transfer information via pulses of light, which pass along one or more, indeed anything up to a couple of hundred in some cases, transparent glass or plastic pipes. Each of these strands is little wider than an average of your hair and will normally be surrounded by a further layer of cladding. It is also in a glass or plastic, but constructed at a different density to the main inner strand. The two primary types of optical fiber cables are single-mode and multi-mode. Single-mode fiber uses extremely thin glass strands and a laser to generate light. Multi-mode optical fiber cables use LEDs. Single-mode optical fiber networks often use wave division multiplexing techniques to increase the amount of data traffic that the strand can carry. WDM allows light at multiple different wavelengths to be combined, or what we call multiplexed, and later separated or demultiplexed, effectively transmitting multiple communication streams through a single light pulse. So what are the different advantages and disadvantages? So noise resistance. External light is blocked by outer jacket. It has less signal attenuation. A signal can run for miles without regeneration currently. The lowest measured loss is about 4% or 0.16 dB per kilometer. It has a higher bandwidth. Currently, limits on data rates come from the signal generation or reception technology, not the fiber itself. The disadvantage: optical fibers are expensive, and insulation or maintenance. Any crack in the core will degrade the signal, and all connection must be perfectly aligned. Clients and servers. Network clients or workstation. Computers that request network resources or services. Network servers. Computers that manage and provide network resources and services to clients. Server is either a hardware or software which respond the services requested by the clients. Workstation is a computer which requests access to the LAN and switch services to respond the request via switch to perform dedicated tasks with having enhanced features. Advantages of client or server networks. It facilitates resource sharing, centrally administrate and control, facilitates system backup and improve fault tolerance. The main advantage of client-server network is the centralized control that it is integrated with. All the necessary informations are placed in a single location. Moreover, if the data were to be lost, the files can be easily recovered from a single backup. Enhanced security. Only administrator can have access to server, and it supports more users. Difficult to achieve with peer-to-peer networks. In client-server network, the data is well protected due to its centralized architecture. It can be enforced with access controls such that only authorized users are granted access. One such method is imposing credentials like username and password. Client-server networks are highly scalable. Whenever the user needs, they can increase the number of resources such as clients and servers, thus increasing the size of the server without much interruptions. Disadvantages of client-server networks. Number one, we have high cost for servers. We need expert to configure the network, and it introduces a single point of failure to the system. The cost involved in setting up and maintaining the server is usually high in client-server network as it does on the network operations. Since the networks are powerful, they can be expensive to purchase. Hence, not all users will be able to afford them. When the servers are implemented, it is going to work non-stop, which means it must be given proper attention. If there are any problems, it must be resolved immediately without any delay. Hence, there should be a specialized network manager appointed to maintain the server. As we all know, client-server networks are centralized. In case if the main server happens to undergo failure or interference, then the whole network will be disrupted. Therefore, client-server networks lacks on the side of robustness. So this is an example of a client-server networks. Network topologies. A topology refers to the manner in which the cable is run to the individual workstations on the network. The configurations formed by the connections between the devices on a local area network or LAN or between two or more LANs. Network topology is the arrangement of the elements like links, nodes, etc. of a communication network. Network topology can be used to define or describe the arrangement of various types of telecommunication networks, including command and control radio networks. There are three basic network topologies. We have the bus, the star, and the ring. It is important to make a distinction between a topology and an architecture. A topology is concerned with the physical arrangement of the network components. In contrast, an architecture addresses the components themselves and how a system is structured in terms of cable access methods, lower-level protocols, topology, and etc. An example of an architecture is a 10-base T Ethernet, which typically uses the star topology. Network architecture is the design of a network or a computer network. So these are example of our network topologies. We have the bus topology, we have the star topology, and we have the ring topology. Bus topology. These are simple and low cost. A single cable called a trunk or backbone segment. Only one computer can send messages at a time. And it is a passive topology, which means computer only listen for, not regenerate data. A bus topology is a topology for local area network or LAN, in which all the nodes are connected to a single cable. The cable to which the nodes connect is called a backbone. If the backbone is broken, the entire segment fails. So this is an example of your bus topology. Star topology. Each computer has a cable connected to a single point. More cabling means higher cost. All signals transmission through the hub. If down, entire network is also down. Depending on the intelligence of the hub, two or more computers may send messages at the same time. A star topology is a topology for a local area network in which all nodes are individually connected to a central connection point, like a hub or a switch. A star takes more cable than a bus, but the benefit is that if a cable fails, only one node will be brought down. So this is an example of our star topology. Ring topology. Each computer serves as a repeater to boost signals. Typical way to send data is through the use of a token. Only the computer who gets the token can send data. A ring topology is a network configuration where device connections create a circular data path. Each network device is connected to two others like points on a circle. Together, devices in a ring topology are referred to as a ring network. In a ring network, packets of data travel from one device to the next until they reach their destination. Most ring topologies allows packet to travel only in one direction. It is called a unidirectional ring network. Others permit to move in either direction called bidirectional. The major disadvantage of a ring topology is that if any individual connection in the ring is broken, the entire network is affected. So this is our example of the ring topology. So disadvantages, it is difficult to add computers, it is more expensive. If one computer fails, the whole network fails. Connecting networks. So we make use of our repeater. So a repeater extends a network. We also make use of our bridge. It connects two compatible networks. It doesn't necessarily pass all the messages across the connection. And we use switch. Connect several compatible networks, allowing it to connect several buses rather than two. Repeaters are network devices operating at physical layer of the OSI model that amplify or regenerate an incoming signal before transmitting it. If they are incorporated in networks to expand its coverage area, they are also known as signal boosters. A network bridge is a device that can create a single network from different and multiple network segments. In other words, it can connect two or more networks. In bridging, the concept is to connect the two networks in order to connect as a single network. Switches manage the flow of data across a network by transmitting a received network packet only to the one or more devices for which the packet is intended. Each network device connected to a single or a switch can be identified by its network address, allowing the switch to direct the flow of traffic, maximizing the security and efficiency of the network. So we have simplex, half duplex, and full duplex. In simplex mode, the communication is unidirectional as on a one-way street. Only one of the two devices on a link can transmit. The other can only receive. The simplex mode can use the intercapacity of the channel to send data in one direction. Example, keyboard and traditional monitors. The keyboard can only introduce input, the monitor can only give the output. In half-duplex mode, each station can both transmit and receive, but not at the same time. When one device is sending, the other can only receive, and vice versa. The half-duplex mode is used in cases where there is no need for communication in both directions at the same time. The intercapacity of the channel can be utilized for each direction. Example, walkie-talkie, in which messages is sent one at a time and messages are sent in both the directions. In full duplex mode, both stations can transmit and receive simultaneously. In full duplex mode, signals going in one direction share the capacity of the link with signals going in other direction. This sharing can occur in two ways. Either the link must contain two physically separate transmission paths, one for sending and other for receiving, or the capacity is divided between signals traveling in both directions. Full duplex mode is used when communication in both directions is required all the time. The capacity of the channel, however, must be divided between the two directions. Example, telephone network in which there is a communication between two persons by a telephone line, through which both can talk and listen at the same time.